Okay, this is the video for the day 2 of Unit 3, the first derivative test homework. What I'm going to do is I'm going to work out the ones on the right-hand side, and you can kind of use the ones on the left-hand side. Hopefully you can work them and then just kind of use the answer provided to check your work. Okay, so remember our first derivative test, what you can do is you can talk about where the original function, over what intervals the original function is increasing or decreasing based on the first derivative test. Our goal here is to take the derivative, then we find where the derivative equals 0 or does not exist, and those give us what we call our critical values. What we do is we then take those critical values and we put them on a sign chart, keeping in mind that a sign chart has to go from left to right, positive, just like a number line, the negatives on the left, in order. And then we test and we plug in numbers to see if the derivative is positive or negative. That will then give us information about the original function, whether it is increasing and decreasing. Okay, so that's kind of our goal. Remember, whenever you're working with trig functions, you should be given an interval here. So we're working with 0 to 2 pi. And so I want to find out where the function is increasing or decreasing. That's a big clue that I want to use my first derivative test. So I go ahead and I take the derivative here. The derivative of x is 1. Now the derivative of negative 2 cosine is going to be a positive because the derivative of cos is negative sign, so you're going to get that double negative, so you get a positive 2 sine x. And again, my goal is to figure out where that derivative equals 0 or where it does not exist. Now because I'm working with sine here, I don't need to worry about where it doesn't exist because this is going to exist everywhere in that interval, so I don't need to worry about that. But I do need to set my derivative equal to 0. So if I set this derivative equal to 0, that's going to give me that 2 sine x equals negative 1, and that sine x equals negative 1/2. So then I kind of ask myself, where on the unit circle does sine equal negative 1/2? And so if you want to know where that happens, oh, I thought I had a unit circle opened here, but I don't, sorry. So on your unit circle, that's going to occur at 7 pi over 6 and also at 11 pi over 6. So that tells me that x equals 7 pi over 6 and also at 11 pi over 6. I can squeeze it in there. Okay, so that's what's happening there. And now those are my critical values. And again, I could call them critical values or critical numbers. I just did critical values there. So I take those critical values and I put them on a sign chart. And so the key part about the sign chart is that I labeled this as my y prime. This is the behavior of the derivative, and it's going to tell me behavior about the original underneath. My critical values are 7 pi over 6 and 11 pi over 6. So I put those on there, and then I plug in a number to the left of 7 pi over 6. So you could choose pi maybe. Okay, so if you plug in pi into the derivative, okay, you're asking for information about the derivative, so I plug pi into there. So if I plug in pi there, the sign of pi is going to be 0, so that times 2 is still 0, so then I get a 1. What I really care about is not so much that it's the number 1, what I care about is that it's positive, so I'm going to mark a positive up here. Okay, so then I plug in a number between 7 pi over 6 and 11 pi over 6, so something between there, and again, this is easier to look at if you have a unit circle handy, but I would pick 3 pi over 2. So when you plug in a 3 pi over 2, the sign of 3 pi over 2 is a negative 1, so it'll give me a negative 2. So 1 minus 2 is going to be negative 1, and I don't so much, again, care that it's a negative 1 so much as that I care that it is negative. Very similar, you can plug in something over here. Okay, so you can plug in, 12 pi over 6, or, that's the same thing as 2 pi, but when you plug in there, you're going to get a positive. So what does that tell me about y? Well, if the derivative is positive, that means that the function is increasing. If the derivative is negative, that means over that interval it's decreasing. And then we have increasing again. And so my conclusion for this one, and again, make sure you're answering the question, I can say that y is decreasing on the interval 7 pi over 6 to 11 pi over 6. And I can also conclude that it is increasing, and there's going to be a union here because I'm going to have from 0 to 7 pi over 6 union, and then again from 11 pi over 6 to 2 pi, because that was my given interval. And that's that one. Okay. In the next section here, it says find the intervals over which the function is increasing or decreasing, then use the first derivative test to find all relative extrema. Okay, so this is kind of a double. We're going to, very similar, we still need to find the derivative, and we set the derivative equal to 0. So here, my derivative, hopefully I can fit it there, is going to be 4x cubed minus 32. Okay. So I take that, and I want to set it equal to 0. Again, I don't need to worry about where this one does not exist, because that's going to exist everywhere. So by setting the derivative equal to 0, well, let's see. I would factor, oh, I don't even need to factor. I could just move the 32 over, so you're going to get 4x cubed equals 32. Okay. Divide both sides by 4, and you're going to get x cubed equals 8, and that is going to give you that x equals 2. And again, that 2 is called your critical value. So I need to take that 2 and put it on a sign chart. Okay, so I take 2, put it on a sign chart, and I'm going to plug something to the left of that into the derivative and something to the right of 2 into the derivative. So when I plug in something to the left of that, I don't know, like a 0. So when I plug in a 0 into the derivative, well, if that's a 0, oh, sorry, up here. If I plug in a 0 there, I get a negative, so this will be a negative there. If I plug in a number like a 3, that'll be a big number. Minus 32 will still be positive. And so that tells me that I am decreasing and then increasing. And so what does that tell me about 2? Well, if a function is decreasing then increasing, that's going to tell me that 2 there is a minimum. And I need to make sure I'm answering the question. So here I can conclude that g is decreasing on the interval negative infinity to 2, and it is increasing on the interval 2 all the way to infinity. And then there is a relative minimum. I cannot conclude that it's an absolute because I don't have any endpoints to test as well. So you could say that there's a relative minimum at x equals 2. If you wanted to go a step further, this question, did it say to give me a point? So yeah, it didn't say that I had to give a point, but if you wanted to give the point, you would take the 2 and plug it back into the original. So 2 to the 4th, then minus 64 plus 4, that would give you negative 40. So you could say that there's a relative minimum at x equals 2, or if you wanted to be more specific, you could say 2 comma negative 40. And again, you get that negative 40 by plugging 2 back into the original there. Okay, so we'll just move this up. And again, you can kind of check your work to the other ones as we're moving along. Okay, so number 6, ooh, quotient rule, that'll be fun. So again, we're still trying to use the first derivative test to find increasing, decreasing, and the extrema. So first derivative test says I need to take the derivative, set it equal to 0, or find where it doesn't exist. Ooh, that's going to be important in this one. So I take the derivative. So it's going to be low d high. So low d high minus high d low, all over low squared. Okay, so there's my derivative. Now, for this one, I would recommend kind of cleaning it up. So be careful here. You might need to kind of do that off to the side with some scratch paper. So you're going to FOIL this out, and then this you just have a 1. So really, though, you need to make sure that you carry this negative all the way through. So if you clean it up, let's see, I got x squared plus 2x minus 3 all over, and I'm not going to FOIL out that denominator. I'm just going to leave it like that. So that's what I got for my derivative, all simplified. And why did I simplify that? Because remember, my goal next is to figure out where the derivative equals 0 or does not exist. Now, I didn't have to worry about the derivative not existing in the other examples, but I do need to worry about it in this example because I have a denominator. So remember, my denominator is not allowed to be 0. So that's going to kind of give us an additional critical Okay, so where the derivative equals 0, that's basically like saying the numerator there is 0. If I set that equal to 0, you could get that by cross multiplying. So let's see, I'm going to say the derivative equals 0, right? Basically, that's saying that I need to factor. So that factors into an x plus 3 and an x minus 1. So that means that I'll have critical values at negative 3 and positive 1. And also, the derivative here does not exist when the denominator equals 0. So basically, if x plus 1 equals 0, so x is negative, x being negative 1 is going to be another critical value. So when I do my sign chart here, oh no, I'm running out of room. So I'll have to sneak in a little sign chart. Okay, so when I put my sign chart on here, remember you need to go in order from left to right. So negative 3 is going to come first. So you have a negative 3 on the sign chart, and then a negative 1, and then a positive 1. And I'm going to plug those into the derivative, plug a number, to the left between each of those into the derivative, and that's going to tell me behavior about the function. So when I plug in a negative 4 into the derivative again, that's why I simplified it. So negative 4 squared, that'll be positive, minus 3, that's going to be positive, over that's a positive, so that'll be a positive there. Then you plug in a number in between there, so say a negative 2. When you plug in a negative 2, you get negative. Then a number in between, 0 is the easiest thing to plug in. If you plug in a 0, you get a negative 3 divided by a positive, so that's still going to be negative. Ooh, I get a double negative there. That's okay. Just make sure your arithmetic's correct. And then I plug in a number to the right, so if I plug in a 2, I also end up with a positive. What does that tell me? It tells me it's increasing, decreasing, decreasing, increasing. Okay? So when you go from increasing to decreasing, that means this is going to be a max. Okay? And then this here, when you go from decreasing to increasing, that's going to be a minimum. Okay? So I do have a relative max and a relative min. And I also have areas of increasing and decreasing. So I'm going to say that f is increasing over the interval negative infinity to negative 3 union, then again from 1 to infinity. And I could say f is decreasing, sorry, got to squeeze it in there, from negative 3 to negative 1 union negative 1 to 1. Notice that I can't just write that all together. I've got to kind of have that union there. And I can also conclude that there is a relative max. So I'll just kind of write that up here. So there is a relative max, okay, at, well, the maximum was at this negative 3. And if you wanted to be more precise to get the point, I'd have to take negative 3, plug it back into the original. So if you plug negative 3 back into the original there, I got a negative 8. And then I can say that there's a relative minimum. That'll be at 1, comma, and if you plug 1 back into the original, let's see, 1 minus 2 plus 1, that'll give me another 1. Oh, nope, sorry, that'll be a 0. Okay. So it'll be 0 divided by that, it'll still be 0. Okay, so there you have that. Okay, so number 7, you should have calculator on it. So you would need your calculator for this one. The easiest way to do this to find the minimum would just be to type that right into your y equals and then do second calc and then find the minimum that way. But using the calculus techniques, the other way that you can do it is to take the derivative. Okay, so this is going to be a product rule. So first times derivative of the second. Remember, the ln of x is 1 over that times the derivative of x, which is just 1, right? Plus the second times the derivative of the first. So when you kind of clean that up, this x and this x are gone, so you just have 1. The ln of x, that times 1 is just ln of x. So our goal is to set that derivative equal to 0 or does not exist. So when you set it equal to 0, okay, so you get this equals 0, you subtract 1, and then this is where people are getting stuck. They're like, well, I don't know how to solve that. Well, remember, to undo ln, you e both sides or raise both sides to the e. So basically what you end up with there, right, so if you kind of e both sides, you get x equals e to the negative 1, or you could think of that as 1 over e. Now this is where I would say you'd need the calculator. So if you type that in your calculator, you get this, and then you do the sign chart, and there you go, the end.